calculate the following. So let's come to this. Let's do this. Let's draw these diagrams together. It will make more sense. We are given that, number one, we have got that. I want to make it a bit bigger. Pardon my drawing there. We have got this with a radius. Please assume this is a sphere. So we've got this which has got a radius, and then we also have a conical flask like this, and we are also told that it has got the same radius, so it's r. But we are also given other information here. It says the perpendicular height they gave us here, height was equal to what? 12 centimeters. And I say, is it centimeters or meters? 12 centimeters. So they're saying, given that both shapes have the same radius, calculate the following: the base radius of the conical lead in centimeters. 3 marks. So they want the base radius of the cone. They want this r. And then what else did they give? Let's look at this. They are saying a spherical lead with a soft metal ball is made by melting the conical shaped lead with a perpendicular height of that. Now, whenever they are giving this, there is always a hint. You need to equate things together. They just gave you the height, you know the r. What is, if you are melting something, you are changing it from a solid to a liquid. The moment you see the word liquid, hello once again, our most valued student. My name is Confident. Welcome to our revision session, and we are looking at this paper, Mathematics N2, written on the 28th of June, and this will be my 4th video. I've already looked at the first question and looked at the second question, question 1, question 2. I've gone on to look at question 3. And in this video, I'm going to focus on question number 4. So what am I saying? If it happens that this is your first time to watch these, it means you've missed 3 videos. Go back and look for these. And remember to be in a position to see these videos as they are uploaded. Just subscribe. Become part of this community. Become part of the family. We are welcoming you to say register, or not really register, but subscribe. Become part of our membership, become a participator in this channel, and you'll be in a position actually to find yourself improving in your results. So there is question number 4, and in question number 4, as I say, it's not a complicated part. It relies mainly on understanding your formulas. Let's look into it. It says 4.1, a spherical lead. Sphere is a round shape, so this is a sphere, spherical. That is a soft metal ball. You see, ball is made by melting a conical shaped lead. So there is a conical, this is a conical shaped item, so it's also like this. It's like a conical shaped thing. Let me not do that. So this is a cone. That's why they say it's also made by melting a conical shaped lead object with a perpendicular height. You see, they are making that to say there is what we call that a perpendicular height of 12 centimeters. Given that both shapes have the same radius, calculate the following. So let's come to this. Let's do this. Let's draw these diagrams together. It will make more sense. We are given that, number 1, we have got that. I want to make it a bit bigger. Pardon my drawing there. We have got this with a radius. Please assume this is a sphere. So we've got this, which has got a radius, and then we also have a conical flask like this, and we are also told that it has got the same radius, so it's r. But we are also given other information here. It says the perpendicular height they gave us here, height was equal to what? 12 centimeters. And I see, is it centimeters or meters? 12 centimeters. So they're saying, given that both shapes have the same radius, calculate the following: the base radius of the conical lid in centimeters. 3 marks. So they want the base radius of the cone. They want this r. And then what else did they give? Let's look at this. They are saying a spherical lid with a soft metal ball is made by melting the conical shaped lid with a perpendicular height of that. Now, whenever they are giving this, there is always a hint. You need to equate things together. They just gave you the height, you know the r. What is, if you are melting something, you are changing it from a solid to a liquid. The moment you see the word liquid, the word volume must come into play. So we're going to find the volume, because it's liquids, of that, and the volume of a cone. So the volume of a sphere and the volume of a cone. Go to your formulas, then that's where you are going to get more answers there. What is the volume of a cone? It's a perpendicular cone, it's a right cone. That's where we are. So the volume of a cone is 1 over 3 pi r squared. And then again, look for the sphere. The volume of a sphere, there it is, V is 4 over 3 pi r cubed. So this is what you're supposed to write down. Volume of a cone, 1 over 3 pi r squared, h. Volume of a sphere, 4 over 3 pi r cubed. So let's come here and write these formulas. Volume of a sphere is 4 over 3 pi r cubed. Volume of a cone here is 1 over 3 pi r squared h. You see that? Then they're saying when you melt this, let's say in a way, picture this, it was kind of a container and having this. You're going to melt this, and then after melting it, it will become like a liquid like this. Then you take that liquid, you're going to form that shape. You see that? So which means you are using the same volume. The volume here, that V here has become the volume there. So what you are simply comparing are the volumes. That's what they're saying. So it means you take this volume and say 4 over 3 pi r cubed, which is the volume of a sphere. It will also give you the volume, the same volume was used to make the cone. That's where they were trying to trick you there. That's where the answer was. You just do that. And then how do you solve it? First things first, get rid of the fraction times 3 times 3. You multiply by 3, you have got 4 pi r squared multiplied by 3, which is equal to pi r squared h. Okay, then after that you can see that pi is repeating there. This is pi r cubed here. I must be sensitive here, very important part. So here 4 over 3 pi r cubed, pi r cubed. And yes, then move on. From here you can see pi is also repeating. Divide by pi, divide by pi. There goes pi. So what do I have now? I have 4 r cubed is equal to r squared h. Now what do? You see, r cubed means there are 3 of them, r squared means there are 2 of them. I can divide by r squared, I can divide by r squared, so that the 2 will go. Remember here there are 2, from 3 1 will remain. See that? So I've got now 4r is equal to what? Is equal to h. But I know my h is 12. So I can then move on to say 4r is equal to 12. Then how do we do it? Multiplication means divide by 4 on both sides. That is that. So r is equal to 4 into 12 is 3 what? Centimeters. What was the question? Find the base radius of the conical flask. That r was the radius, so I've got the r is 3 centimeters. The next question says 4.1.2. So to find the surface area of the conical lid, we need the formulas again for the surface area of the cone. So if you come here to say where is the cone, there is the right cone, and we are looking at the surface area. Now there are two formulas. The one with pi, the first one here is got to do with the h and the r, and the other one is got to the l. There is the slant height. That l is this l, that is your l. We call it the slant height. So we're never given the l, so the first formula is the one. So what you have actually, because I don't want to rewrite this formula, let me work it from here. It will be pi times r, it was 3 centimeters, remember, square root of h was what? Was 12, if you still remember. It was 12 squared, that's what you do, plus r again is 3 squared. Okay, that I made it too long there. And then plus pi times r again is 3 squared. That's it. Then you get the surface area. That's surface area of that. Then equal to, then you get that, and then you get the answer. It was not difficult. So you say shift pi times 3 times square root, it's better to put it times, 12 squared plus 3 squared. See that? Play forward, plus shift pi times 3 squared. You just get the answer straight, 144,852. So you just get that 144,852. They say it in centimeters squared. Are you seeing that? What is the other question? The other question, 4.1.3, it is the surface area of this spherical ball in centimeters squared. Now they want the ball, the surface area of the ball. Again, you come here, you look at your formulas, and I think we have the surface area of the sphere. There it is, pi r squared. So a simple thing, area for A is 4 times pi, r was what? 3 squared. And then you also get the answer there. So it's a matter, as I say, this question was just trickier in you finding r, but after that it is basic. It's 4 times pi times 3 squared, you know. Then that's it. 36 pi SD is 113,097. So 113,097 is what? Centimeters squared. So guys, I don't think it was a difficult one. Go back to the question. That is the last one now that I want to go through. 4.2 is 3 marks. It says use the mid-ordinate rule to calculate the enclosed area by x is equal to 0, x is equal to 14, and y is equal to 0, and the curve passing through the point. This I always find myself arguing at this kind of question, whereby I think for the amount of work and the 3 marks, I feel like they could have given it more marks. This is the mid-ordinate rule. I don't want you to struggle much with a lot of this thing, but I want you to focus on 2 things here. Focus on this. Look, 0, from 0 to 2, it's 2. From 2 to 4, it's 2. From 4 to 6, see? It's maintained by what? By 2. This is actually heavy on the formula. We are going to use the formula on this because they say use the mid-ordinate rule. So you see, it's 2. So what does it mean? If I go to the mid-ordinate rule, see where there it is. The mid-ordinate rule, it says area is equal to distance between ordinates. Distance between ordinates. This is the one. Let me write this formula. Distance between ordinates times sum of mid-ordinates. So if I come here, I'll say distance area is equal to distance between ordinates times sum of mid-ordinates. I'll just do like distance between ordinates, they did this, times sum of mid-ordinates, like that. So area is equal to, that is the distance. Look at the distance, it's consistent, it's 2. So that's why you're writing your 2 there. Is equal to 2 times, now they are saying sum of mid-ordinates. What do you do on the sum of mid-ordinates? Look at this. Since we look at the first one, now focus on 3 and 5, focus on 5 and 7, focus on 7 and 10, focus on 10 and 16. You see, that's what you must focus on, like that, like that. So what do you do? Here we are saying 3 plus 5 over 2. That is the sum of the mid-ordinates. What about the next one? 5 plus 7 over 2. The next one, 7 plus 10 over 2. The next one, 10 plus 16 over 2. The next one, 16 plus 11 over 2. The next one, 11 plus 9 over 2. And the next one, 9 plus 8 over 2. This is that. So you can actually use directly the calculator there just to go through this. So when you do that, you will have 3 plus 5 over 2, and then plus, you are adding sum. They say it's sum. So your next one, it's 5 plus 7 over 2. You continue that, plus, and then you've got 7 plus 10 over 2. Mid-ordinates means, that's why the mid means you're dividing by 2. And then you've got, after 7 plus 10, you've got 10. This one is 10 plus 16 over 2. After 10 plus 16 over 2, the next one is plus 10 plus 16, and then I've got 16 plus 11 over 2. You just keep on repeating, plus, just make sure you don't make error. It's 11 plus 9 over 2. Then you continue plus after 11 plus 9, and then it's 9 plus 8 over 2. You get that? Usually when you see that box, it means the numbers are about to finish. Say equal to, you've got 127 over 2. So here you come and say, okay, times 127 over 2 in bracket. And if you're using the calculator right, that 2 multiplies that 2, the answer there, A, is equal to 127. Done. Guess what? Centimeter squared. If ever they were dealing with centimeters, I didn't check that. No, they didn't say anything. So if they didn't say anything, it's 127. Some they will prefer to say units, whatever unit squared. See, they never gave us any units like that. That is the first formula. What if you prepare the other formula? What if the other formula says area is first ordinate plus last ordinate over 2 plus sum of other ordinates times common distance between ordinates. So we have to write that formula. It's first ordinate plus last ordinate over 2 plus sum of other ordinates. So let me write this out. So A is equal to first plus last over 2, I'm just summarizing, odd, plus sum of other odds, bracket, times common distance between the ordinates. I think it was like that. So what do? You come here. Let's erase now this. Now, distance between ordinates is that distance we're talking about. Is this one. Distance is always common distance. Is the same. That plus 2. From 2 to 4, from 4 to 6. So that one already is answered. You put it here. That is the distance. So you put a bracket here and say times 2. Then first and last, this is what you do. You take this 3 and the last one is what? Is the 8. Then what you do, we add them. 3 plus 8, but you divide by 2. First, this is the first one, this is number 1, and this is number last. I sing that. So you're going to say 3 plus 8. That's what you put there to say A. Maintain my color. Say A is equal to 3 plus 8 over 2. Are you with me? Plus now sum of other. That's where you do the other one now. Instead now you've got 5 plus 7 here. 5 plus 7. And then the next one is what? Let's add this plus 10. Let's add this. We add this. We add this. So it's 5 plus 7 plus 10 plus 16 plus 11 plus 9. Sum of other ordinates. We're just adding that. So if I take a calculator there and add this these ordinates, what do I have? I've got 5 plus 7 plus 10 plus 16 plus 11 plus 9 equal to 58. So I come here and say plus 58. The 58 must be there. Then I can use my calculator now to simplify this. I know it's far apart from each other like that, but let's use the calculator here. What do I have? I have bracket, which is 3. First is a bracket. Fraction, which is 3 plus 8 over 2 plus 58 close times 2 equal to, there it is, 127. So A is equal to 127. That's the area, guys. We got this meshed. Alright, so this is the approach. I repeat, this is the way to approach these questions, and I hope this does make a lot of sense to you guys. Again, if I go back to this question, was it difficult? Not really. It was a 10 marks for you to put in your mark. If there's a bag that you can visualize, it was something to add in your bag of marks. So this was yours. You just needed to not to panic, to calm down and see how you can work your way towards this. Alright guys, we've come to the end of our section. Again, this question 4. I'm going then to bring in the question 5. This question had more marks than question 4. It was out of 20 marks. So you don't want to miss this. Look at this, 20 marks, and it's just simple based on graphs. And 2 graphs that you need to know here, and 20 marks was yours. So I don't want you to lose on this section. Join me again in the next video where I'm going to cover this and show you how simple these were. How can you get these 6 marks just using a calculator, and then how can you answer the questions based on that. It's one of the simplest areas in your mathematics N2. And again, by the way guys, if you feel like you are struggling with concepts of the basic concepts, I've got a book called Mathematics N2 for the Underdog. It helps you to master this concept. Grab hold of that book. It's found on Take a Look. See you again in the next video. Remember to subscribe. Remember to share this channel. Remember to leave your comment. And I am reaching out to you. You need to reach out and also ensure that you prepared thoroughly for your exam. We've come to the end of our section. Thank you.